soon as you start involving all the as soon as you start involving all the phytopathological processes and a complete
Charcoal has been used for centuries as a soil additive to make it more porous, improve fertility and darken its colour to allow quicker warming in the spring. This is a 19th century Norwegian text by Schubler, extolling its virtues and giving instructions on its use. Making biochar is a much newer technology that burns wood at really high temperatures, pyrolyzing, to create a very pure and stable material that has the added benefit of capturing carbon. Usually this is done in large industrial complexes, such as this plant we visited in Norway, Opplandske Bioenergy. But a much smaller kiln has been developed, demonstrated here by Olaf Amund Lie and Knut Arne Jacobsen of the Godjord Company. They began working with biochar about 15 years ago and have had tremendous results with the plants they grow on their nursery, way above sea level and further north towards the Arctic region. When charged with nitrogenous material, usually animal manure or compost, it creates a perfect environment for a huge variety of microorganisms, fungi and worms, all of them making for much healthier soils. Once a really hot base has been created at the bottom of the cone-shaped kiln, a process that can take upwards of 20 minutes, all sorts of timber trimmings and garden waste can be gradually added, ensuring a constant heat of at least 600 degrees. This is then a really useful way for gardeners to get rid of their woody waste, which cannot easily be composted without using a lot of energy to chip or shred it first. It keeps the waste within the garden to create a much more sustainable circular economy. In an industrial setup, wood chip or waste from the timber industry is burned in vast quantities, creating a heat source for neighbouring businesses. The resulting industrial biochar has many uses, including pharmaceuticals, animal feed and agricultural fertiliser, and it's now being used as a major way of storing excess carbon rather than releasing it into the atmosphere as carbon dioxide. Unlike a traditional garden bonfire, this small-scale kiln uses a secondary burn process where the gases return back through the double skin of the kiln, rather like a modern domestic wood-burning stove. It creates a much purer material, biochar, rather than a mixture of charcoal and ash that would be left after a bonfire. The double skin also makes it much safer to operate as it stays relatively cool. Once the kiln is full and the wood burned through, the biochar must be cooled down with water to stop the burning process. A special tap at the bottom allows the wastewater to be collected and poured back on to complete the cooling process. Before using in the garden, it's important to charge the biochar with manure or compost mixed with water to ensure the microorganisms start to colonise the particles. It is then left to mature in a process similar to composting. This can take several days, as long as the material is kept moist. Trials in Sweden with street trees planted in soil enriched with biochar have been very successful, and farmers have been showing very encouraging results using it on the fields. Veja College will be adding it to their potting compost to see how it helps with ornamental plant production, and we hope to return to the college in the next couple of years to see how successful it has been.